I'm gonna talk about a rigid body equilibrium in 2D. Rigid body equilibrium. We learned if we have a particle, guys, I'm talking about before. I talked before about particle. Particle mean one joint, only one point, or one joint, or one particle, just a point, and we have many forces at this point or at this particle in 2D. This particle in equilibrium, that means if you break these forces in x direction and y direction, summation of all forces in x direction or horizontal components equals 0. Summation of all vertical components equals 0. If you are talking about only one particle in 2D and this particle in equilibrium. Later, we talked about particle in 3D, but you are still talking about only one point, one joint, or one particle. And we have many forces in 3D, in X and Y and Z. We have many forces, we have many forces, we have many forces. If these forces are in equilibrium, I can say if you break each force to 3 components in X and Y and Z, I can say summation of all X components equals 0, summation of all Y components equals 0, summation of all Z components equals 0. But this equilibrium only for a particle, one point, and all forces intersect at this point, even in 2D or 3D. But today our topic is talking about rigid body. We have a body. It's not one particle. No. We will talk about rigid body. And we will talk a little bit about some kind of structures. One called beam, the second one called frames, the third one called truss. If you look to this structure, it's a concrete structure. We have something here called column. Can you see this element? This one called column. And we have another column here. In between, we have something here called beam. This one called beam. So beam is a horizontal element rested or supported by 2 columns. If you consider this column with this column and this beam, all of them as one unit, you are talking about something called frame. So the first one called beam, we have a horizontal member supported here and supported here. This one called beam. If you consider the vertical element and the vertical element and the horizontal element, both of them as one unit like this, and the vertical element supported here and supported here, this one can be called frame. If you consider another structure, I believe you watched this structure many times when you are crossing a river or something like this, which called truss, all the time, most of the time, made from steel. We have many members, this member, and this member, and this member, and this member. We have many members. These members connected together at joints. If you find this kind of structure, members connected together at these joints, this structure can be called truss. We will start in this week to talk about this type of structures: beam, frame, and truss. If your major is construction engineer, we have another course called structure analysis and design. We will discuss all of these structures in more details. In this course, we will talk a little bit about these structures. But I have a question. Until this moment, anybody has any question? If you have any question, I prefer go ahead and talk to me directly, okay? I have a question. It's very important to understand this point. It's very important. You don't need to be a construction engineer. I have a question. Do you think this beam, this little beam, is supported by what? This beam in this structure is supported by what? If you are talking about your floor, the floor in a building, you are in your apartment right now. So this floor or this beam in as a part of a floor is supported by what? Any answer? Yes, thank you. Columns. That makes sense. So we have here a column and we have here a column. If you are talking about only the beam, that means we will draw that beam as a line, center line. Center line of this beam can be represented as a line. I don't like to draw column. So I'm gonna assume I have something here called support. What you mean by support? The column looks like triangle? No, triangle is representation. For something here, this representation can represent something is supporting beam at this location. So this indication represents something here at this location. In the real life, it's a column. I don't care about column or something else, but I would like to make something here represent support. So we have something called support. Support means we have another element, we have another member. This member will support this beam at this location. If you consider column as a member and the beam as a member, so we have something looks like this. At this moment, your structure, if you consider column and the beam and the column, all of them as one unit in a structure, this structure can be called frame. Even for frame, by the end of this column, we have here a support. The end of the column, we have here a support. Anybody can tell me this support for this column represent what? Who is or which is supporting column? Not much. It's not a ground, but we have something here called foundation. We have something here called foundation. In this case, we have something called footing. Isolated footing. I didn't draw footing, but I put this support as a simulation or representation for this foundation. You got it? So we will talk today about something very important, which called supports. Supports in the real life means something there, something supporting your structure. Probably this support can be a column supporting beam. Probably this support can be foundation supporting column. You know, for this truss, can you look to this apartment, to this pier or wall, retaining wall on this side or on the other side? We have here support. These supports are supporting this truss at this location. So our topic in this week, we are talking about supports. In the real life, we have something. But in our structure, in our course, we need to represent this structure or this element or this something to be a support. We have three kinds of support. First one called fixed support. Sometimes it can be hinge support or roller support. In the real life, fixed support, this is a beam. This wall fixing this beam at this location. We have many bolts, we have a steel connection, and this connection is fixing this beam at this location. This is the real life. In our problem, in our course, we will represent fixed as this shape. Vertical line with hedge like this, and here is the beam like this. So in our structure, in our problems, if you find this shape in the problem, you need to understand that this support can be called fixed. If you found fixed support, that means we have three reactions. As you know, supports are used to support the structure. So we have something called reaction. Can you let me know what is the meaning of reaction? Yeah, I can. On this slab, you are standing here. That's right. And your laptop is here on a table. So we have load. You represent a load on the floor. This floor is supported by these beams. These beams supported by column. So we have load coming on the beam. That means column will react to support this beam. So you are action. You are a load. So you are action. Your desk is action. Your laptop, your dressing, everything in your apartment is action load. This action load coming on this beam. So column is supporting the beam. So column will react. So we have action and reaction. Okay, your load will coming to beam and then coming to column. The role of this foundation to react. So we have reaction coming to this direction. This reaction will balance or will be in equilibrium with the action force. Then your structure will be in equilibrium. So if you have a support, we have something called reaction. How many reactions do you have? Based on what type of support do you have? If you have fixed, we have three reactions. One vertical reaction as a force, one horizontal reaction as a force, and one moment. So we have three reactions. Vertical force, please, this topic is very important. Vertical force, horizontal force, and moment. if you have a fixed support. Sometimes we have something called hinge or pin support. Pin support looks like this. So in our course will be represent like triangle with base and this triangle connected to the beam. If you have something like this, which called hinge or called pin, this support will have two reaction only, one vertical and one horizontal. We don't have moment, no moment. We have only two reactions, one vertical force, one horizontal force. So if you found something like this shape or this symbol represents something in the real life, as you see here. The third type of support called roller support. Sometimes, especially for bridge, if you watch a bridge, sometimes under the beam of the bridge you can find a cylinder like this one. This cylinder represent for this beam or this column as a roller support. Roller support, if you have a roller support, we have only one reaction. Only one. This reaction is perpendicular to this base. I'm sorry, can you make it more clear? Yeah, the roller support looks like triangle rested on roller like this, and we have base. And this triangle connected to a beam. So we have only one reaction. Is it vertical reaction? Is it horizontal reaction? No, not horizontal, not vertical, but this reaction perpendicular to this base. What do you mean by perpendicular? I mean, sometimes your roller probably looks like this. Sometimes this roller looks like this. So if you have roller support, we have one reaction as a force. This reaction is perpendicular to the base of the roller. That means your reaction here will be in this direction, perpendicular to this base. That means your reaction will be like this, perpendicular to this base. So the rule is, if you have a roller support, we have one reaction. Which direction? Horizontal, vertical, or inclined? I don't know. Based on the position of this base. Put your hand on this base, draw your reaction perpendicular to this base. Okay? So one more time. We have three kinds of supports. Fixed support, hinge, or sometimes called pin support, or roller support. If you have fixed, we have three reactions. One vertical, one horizontal as a force, and one moment. One moment. Moment looks like have circle, like this. If you have hinge, we have two reactions, one vertical, one horizontal. If you have roller, we have one reaction perpendicular to the base of the roller. Guys, any question so far? Any question so far? Okay. So today we are not talking about one point or one particle. No, we are talking about a body, and this body is rigid. So we have in 2D, we have a new, and this body also in equilibrium. So we have 3 equilibrium equations. Summation of all forces in X equals 0. Summation of all forces in Y equals 0. And we have a new equation today, summation of all moment equal 0. Just keep the 3 equations in your mind until this moment. So if you are talking about body, rigid body, in equilibrium, we have 3 equilibrium equations. Summation of all forces in X equals 0, summation of all forces in Y equals 0, and summation of all moment at any point equals 0. Moment, if you go back to physics or mechanics in math, moment equal force time distance. If you have a force 50 kilonewton, for example, and you have distance 5 meter, if you multiply this force by this distance, the product will be a moment. So moment, this moment as a reaction, or this moment as equilibrium equation, is a force time distance. Keep in your mind, not any force, not any distance. No, your force and your distance must be perpendicular. I'm sorry, what you mean by perpendicular? I mean, if you have a force, vertical force, like 50 pound, your distance must be perpendicular to this force. So this distance must be horizontal, 5 feet. If you multiply 50 times 5, the product will be a moment. Or if you have a horizontal force like 20 kip, for example, your distance should be what? Not should be, must be what? Your distance must be vertical distance, 20 feet, for example. So be careful. Not any force and not any distance. No, your force and your distance must be perpendicular to be produced to get a moment. We have 2 very important rules here. Your moment is a force time distance, and your force and this distance must be perpendicular. Sometimes we can assume positive direction as clockwise or counterclockwise. I will cover this later, next time. So what we learned today, we are talking about rigid body. Rigid body means we have body. It's not a particle. And this body, or this rigid body, can be beam or frame or truss. We learned we have 3 types of supports. The first one called fixed support, roller support, hinge support or roller support. Hinge can be called pin. If your support is fixed, we have 3 reactions. Hinge, we have two reaction. Roller, we have one reaction. And this reaction must be perpendicular to the base of the roller. If you are talking about equilibrium of rigid body in 2D, we have new equilibrium equations. Summation of all forces in X equals 0, summation of all forces in Y equals 0, summation moment at any point equals 0. I will discuss this equation in more details next time. But in your mind, moment means force time distance. It's very important. This force and this distance must be perpendicular. Okay? Let me stop here. That's enough for today, and I will continue next time. But anybody has any question?